Thanks so much for the intro. So yeah, I'm working at Klein. I'm the head of AI at Klein, working on building effective AI coding agents. So this talk is going to cover some of the lessons we've learned building real-world coding agents in production, some of the challenges, some of the kind of tantalizing ideas that don't really work, as well as talking about like this common thread of over-engineering your agents, all kinds of like clever engineering ideas that don't work in practice, and also things that we're not focusing enough on, namely evals, what evals are, what an RL environment is, and how we're solving some of these challenges at Klein. So, okay, so yeah, stop distracting your coding agents. So I'm going to start by talking about RAG and kind of the original promise of retrieval augmented generation. So back in like 2022, 2023, there was all of this hype around RAG where the promise was long-term memory, that agents have very restrictive context windows. At the time, it was like tiny, like 32,000 tokens max. And RAG was like this catch-all solution that the promise was that it will give your agent or your AI long-term memory. And there's like a number of promises made, like in this Pinecone article that was very popular at the time, where they promised to ground LLM responses in real documents, pairing models with vector databases to simulate persistent knowledge without fine-tuning. And instead of training on like some kind of niche use case, you could just use RAG to immediately retrieve the context that you need to generate an answer. And at the time, everyone invested into this, like all the usual suspects: Andreessen Horowitz, Sequoia, Menlo Ventures, Benchmark Capital, to name a few, but a lot more. And not everyone invested in Pinecone. I'm just using Pinecone as an example. But there's like a bunch of other RAG startups at the time, like Weaviate, Chroma, Quadrant, not sure how people say that. But and at the time, it actually kind of worked. So it empowered me to build an open source project called Vault, which kind of blew up at the time. I actually built like a little demo application on GitHub of like how you use this, and I published the source code online, and basically it was like just pushing people to set it up themselves and start using it. But instead I found just a lot of people using the website, the demo website that I published. Very quickly, my context limit, my quota for OpenAI just went through the roof, immediately blew past all the limits. So I ended up like turning it into like a little product at the time, kind of like a chat PDF style product, and started building up like a user base there. Became very popular in open source, and that led into a lot of people coming to me to like ask me for my advice in terms of like building retrieval augmented generation pipelines and systems like that. So very quickly I became very experienced in what it means to actually run a retrieval augmented generation pipeline in production, how to optimize retrieval augmented generation pipelines. And it turns out it's a little bit of an art form because it's not deterministic, and you have to actually measure things in production. You have to measure things like cosine similarity scores, re-ranker scores, and kind of plot them over time and optimize and hill climb on that. But at Klein, I actually became the #1 advocate against using RAG for your coding agents. And I want to kind of dive into why. So back in May, I published this article on Substack that quickly blew up and caused a little bit of a stir. Yeah, there we go. Where I basically talked a lot about what I'm going to be talking about in this talk, but at a broader level. And the core thesis of that article was that RAG just isn't needed in a coding agent context. So the unique thing about the coding domain is that code is inherently logical and structured. I mean, I'd hope your code is logical and structured. You don't need to index your whole code base, which is a security nightmare. If you look into like what actually goes into that, you have to index the user's entire code base, send it out somewhere to the cloud. That's fundamentally insecure. A lot of people think that embeddings, vector embeddings, are almost like hashes, encrypted hashes, where you can actually, it turns out you can actually just reverse engineer a embedding into the original contents. So it's not actually this kind of one-way encryption that people expect it to be. And instead, what we found worked at Klein was you can just ask the coding agent to explore the code base using tools like grep or read file, look at the tree of the repository and explore things that way, and that just works a lot better. And this is a good example of an average coding agent lifecycle task, right? You have, the agent starts out in plan mode, and in Klein we actually have two distinct modes where you start off in the planning phase, and then you switch into act mode where your agent goes in and starts executing on the plan that it created. And in plan mode, you see a lot of things like file reads, maybe terminal executions for grep, general search capabilities that the agent has, search tools. All of that happens in plan mode, and then the agent generates a plan, and then you switch to act mode and it starts executing. So, and Klein does this really, really well. You split things by workspace. You can quickly glean what's going on, what the agent is doing. And in this kind of real world scenario, where do I have that example? Like in this example, for example, I had Klein look at a specific PR, understand the changes that were made using the GH command, which is super helpful for agents, pull down the entire diff of the code, and start generating a plan from that. So yeah, all this works really, really well. RAG is not needed for any of this. In response to my kind of short piece on Substack, Pinecone came out with this blog post later in June where, in a nutshell, for lack of a better term, they were like kind of coping with what I wrote. They kind of try to marginalize a lot of the points that I was trying to make, where their response was basically, they said like, oh, RAG isn't actually dead. It's critical. They said that the problem isn't RAG, it's the way you implemented RAG. They talked about like hallucinations, that hallucinations are somehow like a big problem, and that RAG gives you control over hallucination, which is not fully true anyway. And they came out with this kind of novel concept of like agentic RAG, where if we want to talk about complexity, they actually showed this complexity in this blog post. They kind of did the work for me, where they came out with this diagram, and it just kind of shows you like how complex their proposed solution really is. And my response to this is just like, you're solving 2022 problems with 2023 tech. Everything that they call a limitation, like hallucinations or outdated knowledge or context limit, is kind of irrelevant today with flagship models and massive context windows and basic tools like grep or read file. And this just ends up being like this massive bloated workaround system that you need to then end up maintaining and optimizing. And yeah, it ended up being kind of like lipstick on a pig, slapping an agent on top of a brittle RAG pipeline that just added a bunch of complexity and latency. And then you had to like think about all the work that it takes to like optimize the system, which is fundamentally like a black hole for resources. It's like you can sink so much time and energy, and I know firsthand, you can sink so much time and energy and resources into optimizing your RAG systems, where it's a little bit of an art form. You have to look at re-ranker scores and cosine similarity scores, figure out what's going wrong, where instead you could just remove this whole system and give access to basic tools like grep. So this ties in with like the larger, bitter lesson of building agents in general, and in particular coding agents, where the idea is you have all kinds of tantalizing ideas when it comes to building agents. You have all kinds of clever ideas that engineers might come up with, and they just don't hold up to the bitter lesson. And for example, Boris from Claude Code famously came out and talked about how they tried out RAG when building Claude Code, and then they ended up switching away from it because basic tools like grep outperformed everything by a lot. So in a nutshell, modern models don't need it. They have 200,000 plus context windows, 1 million context windows. You can feed in real files directly. You don't need a chunk or deal with this like schizophrenic mind map, like hyperdimensional clusters of embeddings to be able to understand what your agent is doing. And there's also like a separate point is that RAG actually distracts your coding agent by introducing this kind of vectorized embeddings and having your agent search for similar chunks. You end up getting just hundreds of these like search results that end up fundamentally confusing your agent. It's like imagine you're trying to read code, but all you get is like little disjointed search results of like little coding snippets all over, like clouding your mental space. So this kind of concept of the bitter lesson doesn't apply to just RAG. It applies to all kinds of clever engineering ideas. You have RAG, obviously. You have fast apply, which became kind of a popular thing back in, I believe, like June of last year. It even applies to like fancy static analysis tools like CodeGen, where famously CodeGen, like 2 months ago, they came out on the timeline and they said that basically it's like full capitulation. They've been building CodeGen, which is like their bread and butter has been fancy static analysis tools, kind of like a SQL-like language knowledge graph to query like a knowledge graph of your code. And they just came out and said like, hey, none of this really works. We just give our agent grep and everything works better than that. And multi-agents, sub-agents, I'm not sure about. I'm still hesitant when it comes to these. The jury is still out when it comes to multi-agents, sub-agents. Like, do we really need them? There's many cases where, you had things like Crew AI 2 years ago, which the promise of multi-agents was like, hey, you could have all of these like agents that are super specialized at their individual tasks work together and solve very challenging problems. And that seemed very appealing at the time, but in practice, anyone that used Crew AI or like things like AutoGPT at the time quickly realized that it was a quick way of burning a lot of tokens and getting nowhere. I think there is still a lot of potential for things like sub-agents, and in particular read-only sub-agents, where it's just gathering context and research. I think there's a lot of potential there. But when it comes to generalized multi-agents that can go wild, run wild on your system and make changes and execute on tasks together in a unified way, I still have not seen that work for anyone. So in terms of RAG, it's not fully buried yet. RAG can still be useful in a number of contexts if you're trying to keep things cheap, but still have perfunctory performance. If you have like a fixed subscription model where you have like a fixed price monthly that you're trying to like neatly squeeze your users into and make money off the margin, it could still be helpful. But in general, if you want the highest quality, you wouldn't use something like RAG. You would go full context heavy, read entire files, and use idiomatic search tools that the agent has access to. So we've over-engineered agents, but we've under-engineered evals. This is the next kind of segment of my talk where I want to talk about how there's all these clever ideas that we try to over-engineer our agents with. None of them work. We want to keep things as minimal and simple and close to the model as possible. But there hasn't been enough effort put into evals. And like a month or two ago, there was this wave of people bashing evals on Twitter. I don't know how online a lot of you guys are, but there's a lot of people saying like, why do we even need evals? People were saying like, fuck evals, we don't need them. we spent so much time building evals, but we realized that like we just ask users for feedback and we just do the check and things work a lot better that way. And my response to that is that evals are more important than ever. And to respond to these people asking like, well, you know, why do we need to build eval systems when we could just ask people what works in production, use basic telemetry to optimize our agents? We have to kind of start at the basics of what is an eval. And it's actually quite simple. An eval is just an environment. Typically, this is something like a Docker container in the case of like things like Terminal Bench or Prime Intellect's Environments Hub. You have a starting state inside of this environment where you have the snapshot of the repo, for example, when a user was working on a real-world coding task, the state of that repository before they started working, and the starting prompt. And then you have a verifier at the end, which is increasingly becoming the meta for a lot of these frontier model labs, where the verifier checks whether or not an end state is correct or acceptable. So typically these are like things like unit tests at the end that check where like if the code works, if the coding agent at the end of its task submitted code that fixes all the problems that the user wanted to fix or implemented the feature properly. So how are RL environments different? Well, you might notice it's actually the exact same thing. RL environments and benchmarks are actually the exact same thing, and a lot of people don't realize this. They're not really different at all. An RL environment is that exact same system, like an eval, but the only difference is how you use the output from the verifier. Instead of just putting it up on like a leaderboard, you end up integrating that into your training loop and updating the model's weights based on what the verifier put out. So the only real distinction between an RL environment and a benchmark is how the reward is used, and the TLDR is benchmarks measure models and RL environments improve models. So in doing a lot of the research, we're working on ClineBench, which is a real-world agentic coding benchmark based on real-world tasks, not synthetic data, not academic-style tasks where you come in with like a massive spec as your starting prompt. This tests for real-world interactions. In doing a lot of this research, I kind of came across a common thread of looking into things like Terminal Bench and Prime Intellect's Environment Hub. And there's a common thread, kind of reading between the lines, a pattern emerges, and basically the industry is moving towards what I call evaluations 2.0, where benchmarks and RL environments are converging. They're starting to become the same thing. And together they hold the key to the next leaps in model capabilities. Application layers that sit in between the models and the users hold the ingredients to build these real-world benchmarks, but few actually realize this. And Evaluations 2.0 is all about standardizing all of this, standardizing RL environments and benchmarks, making them easy to set up, making it easy for people to contribute new cases, new tasks to a common hub, in the case of Prime Intellect's Environment Hub, and be able to run it anywhere and train their models easily on top of it. So at ClineBench, we realized like, hey, we sit in between models and users. We're uniquely positioned to build a benchmark that benefits the whole industry. And instead of trying to get all clever with a bunch of interesting ideas like RAG or optimizing the way the agent is able to search, which is still important, but ultimately results in marginal benefits, let's focus on actually building benchmarks that make the models better. So with ClineBench, it's a clear example of this. It's designed to test reasoning, clarification, and adaptability, not just completion. It's designed to test real-world agentic coding tasks, and it's designed to be seamlessly integratable, like with amazing DevX to be able to easily integrate it and contribute new tasks or put it into your own RL environments and improve your models. So in terms of what actually moves the frontier, it's not clever agent engineering techniques that don't make models smarter. It's not introducing a whole bunch of complexity to your coding agents. It's actually the opposite. You want to keep your agents as simple and close to the model as possible. Instead, focus on evals, focus on making the models better. Every improvement that you see when Model Labs hill climb on your benchmarks lead to better performance and more consistent, reliable agentic experiences. And the frontier is now about building these little sandbox environments of tasks, real-world tasks that anyone can run to improve their models. So this is a good quote by Karpathy, where he talks about some of this stuff. So that concludes my talk. I don't know if we have time for questions, maybe one or two, but yeah.
Yeah, thanks for the talk. One thing that's different about coding is that there's like a nice semantic hierarchy in your file system, right? But say you're an enterprise assistant and you have 50,000 PDFs. I mean, sure you need RAG, right? What's the alternative there? How do you let an agent navigate if you don't have a structurally meaningful file system?
Yeah, that's a great question. What's interesting is I'd say that that's one use case where RAG could still be relevant is if you have a massive data lake of unstructured data, a bunch of PDFs like you described, where at that point it's like, yeah, sure, index all of it, throw it through vector embeddings, and use RAG to retrieve context. However, this kind of starts breaking down the second you have any form of structure to the data. And a good example of this is I was actually using Klein to build out an API that uses like ADIO, which is like a CRM, so that we could automatically enrich users, or actually it's Apollo, so we could automatically enrich users that signed up for Klein. And they had this big LLMs.txt that summarized all of their docs. And in the LLMs.txt, they didn't just have like all their docs in one page. They actually had links out to other websites, like other markdown text, where it would link to like another page, like, oh, this is like the person's domain, the people domain, or the organization domain. Here's some more docs for that in like a separate page. And this kind of showed you like there's like some structure to it. And I had Klein basically read LLMs.txt. I gave Klein access to like the Firecrawl MCP server, where it would read the link to the markdown file for companies and be like, oh, I need to look into that. Okay, let's fetch that. And then all of a sudden it's the same thing as like a repository where you have like this nested structure, but it's plain text English, but it's the same idea, right? You can read the overall hierarchy and then dive into more details in an agentic way. So you don't actually need RAG in that case.